Well, hi, good morning. Thanks for coming and spending some of your time with me here in my shop while I work away on this, what I think is going to be a fantastic radio once it's all fixed up. In fact, it was working pretty good right from the start. So I appear to be just working my way down through the radio, replacing capacitors one stage at a time. And I'm down in this level now. The next tube to do is going to be this one here. But this big capacitor's caught my attention, and I think I got to deal with it now. It's not connected to a tube base. It's connected between, well, it's connected to the chassis here. And the other end is connected onto a terminal strip, and who knows where it's going from there. I don't know offhand. It's a fairly large capacitor. It's either a 1 or a 0.1. I can read the number 1 here. There's probably a decimal point I can't see in here. In fact, I think I can start to see it now. So I'm pretty sure this is a 0.1. The physical size of this is a lot larger than the other capacitors. What's it doing that it needs to be a big one? And my guess offhand is it's attached to the screen circuit, and its job is to drain out any unwanted RF signals that might be in the supply part of the screen circuit. Don't know that for sure though. So I want to hunt it down because it's connected kind of in the middle of stuff. It's a little bit tricky. It's actually connected to this terminal here, and coming from here it's all wires. So wire to here. So trying to trace it to somewhere certain goes to this meter. Yeah, one line goes to this meter socket. These two large resistors go to the meter socket. Well, we'll get to that at some point. I don't think, if this is involved with the meter, which I kind of doubt, excuse me, we'll eventually get to that. That'll be one of the last things I work on, is trying to make the meter up here operate. Well, as far as I can see, there's only one big guy like this. Find him on the list of parts, find the part number, then find it in the schematic. I'm going to try and do that. So start with the parts list here, and how many big capacitors are there like that? A 1 or a 0.1? There's a 0.1. That's it. That's it. That has to be the guy. And what's it called? RF bypass power supply. Okay, where's it located? Hang on here while I hunt down the diagram. Here we are. I already found it. It's over here. Number 15. Where'd you go? There it is, 15. And you'll have to trust me, this is pointing right in the area where that capacitor is. So I think that's the right capacitor. Now, can we find it on the schematic? So it said power supply. Okay. This is the correct schematic this is the most correct schematic for the capacitor I've got. The part numbering may be different here. See, these are all big numbers. C38. Doesn't mean it's right in the power supply on the schematic. I don't think we're going to be able to find it here just by running around. So I'm going to stop doing that. It's got to be a 0.1. I got to find out if I have a 0.1 to put in there. We'll probably stumble on it at some other point and realize which one it is. Yeah, I'm not going to find it here. Just running around. Okay, I'm going to replace that with a 0.1. Okay, I've replaced that capacitor now, and I've got 5 here to test. I guess I've fallen behind in the testing, and I think I lost track of one capacitor. I found it. So it's in this bunch here. Let's start with the one I just replaced. Big capacitors take a little longer to charge up. And until they charge up, you can't really see the leak. So this is going to close probably for a little bit. Let me just relocate myself here. Again, it's very hard to see the eye here. Seems to vary from day to day. My camera. Here we go. Okay, it's opening. It's opening. It stopped about halfway. That's at 50 volts. 150 volts. And it's not going to open at all. So the capacitor is testing very similar to all the rest. It's testing bad. Poor. Poor would be the right word for that. Let's just run through these quite quickly. Here. $50 volts. What do you say? What do you do? Doesn't want to open. Maybe I tested these already. Forgot. Usually, after I test things, I throw them out or put them away somewhere. Here we go. How about this one? Open right up. 150. Just, you can't see it, but it just opened a wee bit. So, not different than the others. No surprise here. This is the guy I think I lost track of. There we go. That's 150 volts. Whoops, about 50 volts. 50 volts, it's happy to open. 150. I'm not going to do it. So a good capacitor pops right open with 450 volts put on it, on this machine. Okay, how about you? 50 volts. Not going to open. So my qualitative judgment on these things is if you can get up to, let's say, 350 volts and the eye is still open to some degree, the capacitor's probably got a lot of life left in it. It depends upon its position in the radio and what its job is. In some cases, a little bit of leaking. I don't think it's going to throw the radio off too much. Okay, but so far, every wax capacitor I've taken out of this radio has indicated on test that it should be replaced. So, no surprise there. Next tube to do will be this one. So we're going to take the resistance readings here. See that this capacitor is nearby, but it's actually connected to this terminal strip. This guy's right on the capacitor, and they're both going to ground down here. So probably more decoupling or capacitors intended to remove, quell, eliminate, block, absorb RF power. So, okay, I'm going to stop for a moment and get my meter and get ready. Okay, first test is pin 3. 330 ohms. Now I've got my meter grounded here to the chassis. Right up in here. Pin number 3. 330 ohms. Oh my. So I'm on the 600 scale. Let's check this. This should be a 0. Something not quite right here. Let's try a different clip lead. 330 ohms. Oh boy. Oh my gosh, what's going on here? Something's not right at all. Oh, you know what it is? They've got pins 1 and 2 joined together, and I counted them as 1. This is pin 3. Ooh, 900 ohms, and it's supposed to be 330. Well, we're already onto something here, because again, that's just too far. 330, so it looks like it's this resistor here, this little guy. Orange, brown would be 330. Let's go right across it here. 330 must be another cathode resistor. That's pretty important too. There's the number 882. Okay. The next target here is going to be replacing this little guy here. 330 ohms. Okay. Oh, I've got some unusual looking resistor here. It says 330 right on it. 330. Very good. We'll put this guy in. Fantastic. Oh, I think it's time to give the radio a test now. Let's just put away the Allen meter. Why do I call this the Allen meter? It's a unity, because somebody named Alan on the east coast of Canada sent this to me to help me out. So thank you very much, Alan. I'm using your meter regularly. Okay. We look safe here. Nothing funny going on. Whoa, 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 whoa. Okay, plug it in. Check volume down. Red. Everything's set to red. Selectivity. Here we go. Switch on. Okay, dim bulbs look okay. That's good. No smoke issuing forth. No flames, no nothing. Full power. Okay, we're on the broadcast band with no antenna. I'll be the antenna when the time comes. Come on, radio. Silence. Ooh. 116 volts. Why the silence? Why the silence? Okay, rather than use my finger, this is just going back to the loop antenna behind me. I'm just hooking up one wire because I just want to hear some noise. Make some noise, radio. Yikes. Oh, it's so quiet. That's not good at all. Why so quiet? She's gone downhill. So something like this usually indicates a mistake has been made. Working away on the radio, it's getting weaker as I go. How come you're like this? Band switch. Turn the volume down. No? Another band? Everybody's gone quiet. Okay, so do I carry on or do I say, uh-oh, something's gone wrong here and I better sort it out? I think I better sort it out. Oh my, this is not what I wanted to have happen. Right, okay, first of all, let me put this back here. is I'm beside myself now. Volume up. Sensitivity. You've killed it, Jim. You've bloody well killed it. ABC off. Well, that made quite a difference. Well, made some difference. Oh boy, what have I done? I've done something. Try as I may. Okay, let's first see if anything's getting hot in here. I happen to have my thermal meter handy. So if nothing's getting hot, then we can just kind of mess around here for a while. Okay, so it's let me just change the settings here a little bit so it doesn't look so dramatic. Okay. What is getting hot? So there are some things. These two resistors. How hot is hot? You know, not quite 60. This guy. This guy. All the high wattage resistors. That's like normal. This one's getting warm. There's another big high wattage one back here that's getting warm. Just the high wattage resistors warming up. Nothing bad if there's another fairly high wattage resistor here, probably a cathode resistor if I remember right. So there's nothing bizarre getting hot here. Another high wattage resistor here that's warming up a little bit. So how come you're not working, radio? Like, how come? Why'd you decide to do this? Just to be a trouble. Okay. We should check something. Fooling around with some high voltage circuits here. We should see what remains of the high voltage. Take this off. Nothing coming through. It would appear. It would appear to be the case. Do I remember what the supply voltages were? I gotta clip this on, I think. I'm gonna have to worry about one thing. I'm sticking in the radio instead of two. Okay. Big B plus. A little scary there at first. What's going on? 215, 271, and the other side of this resistor. The big 360. Okay, it's all there. Is it making it to the tubes? Let's pick one that's easy to test. It would really be, let's try this guy. This is the 6SK. Just gonna go around. Looking 6 volts. What's 6 volts doing there? 6 volts. What is that? It's all about. There's 100. That sounds a little low. Here. 0. 270. So that sounds like a plate. Sounds like a screen on the other side of this big guy who's probably got a high voltage here. Ooh. 100 volts on one side, 0 on the other. What's happening there? That doesn't seem right. That does not seem right. Okay, let's see. We can sort out. You know, it could be something coincidental that's happened. So I don't have to immediately blame myself. So this is the, which tube? This is the, okay, so that, the reason it might have a 0 there is this is the detector tube. Detector tube, 0, 0, 0 ohms. Wrong table, Jim. Volts, 0, 0, minus 0.4, minus 0.4, minus 0.9, and 6 volts AC. So there's no real voltage there to be seen. Just a little odd. It has this great big high wattage resistor here. Possible this terminal is doing nothing. Being used as a ground point. It is actually. You know what? It's grounded. This terminal's grounded. So this is a resistor to ground. A great big high wattage resistor to ground. Off of this tube, which is the first IF tube. First IF tube voltages. First IF tube 6 SK. Which pin is this? This is pin number 1, 2. Count them right now. It's so hard to see. Yeah, I've done 1 and 2 together. So 1, 2, 3, 4, 5. Pin number 6. Pin number 6. Voltage table. First. First 6 SK7. It's not right, is it? RF mixer. Yeah, first 6 SK7. Pin number, did I say 6? 1, 2, 3, 4, 5, 6. Pin 6. 105 volts. What it's supposed to have. 105 volts. Pin 6. 100 volts. So that tells me the B plus is going through the radio. Nothing seems to be pulling it down. Nothing's getting overly hot. The next suggestion is I put in a part and then didn't solder it. Where's the volume? Oh, that's soldered. I checked all these. Oh my gosh. If I go forward, I run the risk of introducing another error. I'm assuming I've made a mistake. Introducing another error. And then, wow, tracking it down is pretty tough. Well, how did I boot this up? So we know there should be a IF, well, only if I'm feeding an IF signal. Yeah, you know what? Time for coffee. And stop for a minute and think about this. Think this about. Oh, it didn't take me long. I just 2 seconds went by. Right away I realized what the problem is. The problem is I don't have a speaker connected to this radio. Now that's curious, because I turn this thing up, I could hear something. You can hear it too. No speaker attached. It's what would that be? What would goodness knows. Put the speaker on, she's got plenty of volume. Okay, so I didn't make a mistake, except I made a little mistake. Let me take this off here so it's not hanging. Yeah, once I hook the speaker up, I won't be able to hear that thing. What is that thing? Swing this around. I've got to turn the volume up again. So it's past the volume control. Well, what could it be? Anywhere there's a transformer and coils, it could be vibrating and turning into a speaker. Maybe the output tube itself. This is very interesting. I need something here. Okay, so you guys got to move out of the way for a second while I fish something off my wall here. You guys, there's only one of you. Something I don't use very often. Come on. Tangled up in all kinds of stuff. Like a stethoscope. Guard your ears. Well, my ears. Guard my ears. Hello, testing. Is this going to work? Oh. It's one or the other or both of the audio tubes. Okay, so they're working hard there. Got the volume cranked up. Okay, let's put a speaker on now. Interesting, and that's not too surprising, is it? You can hear the tube itself. I've never heard the tube itself, but it's not surprising to me. You can picture the elements shaking inside based on the electric fields that are in there, causing the tube to, and you know, we know about microphonic tubes, which is the opposite. You shake the tube, the parts shake, and the sound is reproduced. Yeah, it's kind of interesting. And I've even heard of situations where you can have a speaker mounted to the chassis of a radio, and then the speaker's output can shake the tubes enough to cause feedback if you have microphonic tubes. Okay, that's interesting. Let's put on the speaker here first. First of all, make absolutely sure the volume's down. Grab my speaker leads. So is it good to operate these guys without a speaker attached? It changes the... it's probably harmless, certainly with the volume turned down, probably quite harmless. The volume turned up full, maybe not so harmless. But you can see I'm not too worried about it. Okay, this has to come around here. Gotta remember where I hooked them up. Where did I hook them up? One in here. Jeepers creepers, I can't remember. Okay, one definitely here. And then one of these two. Volume, please. She's alive and well. Okay. Well, that was good. It was good for me. Was it good for you? It was good for me. Okay, we're going to put that over there. This wire flying around in space. Good enough. Not a lot of volume. Oh, no, antenna. Okay, antenna. Lots of volume. Loads of volume. Okay. Okay, that's like a reprieve for me. We will cut the power now. All is well. Got a chance to use the thermal viewer. Nothing overheating. That shouldn't be getting warm. I will carry on. Okay, so the next tube we should do is the detector tube. We have, what do we got left? We have detector tube, then we have audio preamp tube, separate tubes in this case, and then we have the output tube, which I've already fiddled with. But looks like I left capacitor. So this guy next. Now I've had the set operating, so making resistance tests. I should wait a little bit. What? No, not me. That's the ham radio repeater in the town of Aurelia, the ham club. Okay, and what time is it? It's 11 o'clock, so they're going to start their 11 o'clock coffee meeting. Hey, they're doing coffee. Well, I'm going to do coffee too, but I'll do one quick. Is there any voltage left in here? Any voltage still left in here? Nothing there. No, there's nothing. Okay, coffee for them. Coffee for me too. Okay, so there's two capacitors here, that one and that one. They're both tied to the detector tube, and this is a two-part detector tube. It's a 6H6. One part I'm pretty sure is doing the audio detection. The other part, I'm not sure what it's doing, so we'll look at the schematic, kind of sort that out. One of these is on pin number 1, 2, 3, 4, and the other one, they're both going to ground. Maybe not this one. This one's going over here, so we have an ungrounded one here. But this one's going to ground over here, and it's tied to this terminal, which is busy. Wires going here and there, but one of the wires comes along, gets on pin number 1, 2, 3, 4, 5, 6. Pin number 6 with a huge solder blob. Wow, so close to a short circuit there. The big solder blob almost got over to the other terminal. That'd be like a millimeter or less in between. Probably less. Wow. Okay. Let's look on the schematic and we'll try to find these guys. I can't see their sizes. He says while he's looking. No, but this looks a little smaller than that. That's probably a .05. Not sure though. Okay, to the schematic. Okay, I come down here and there's the two-part tube here. There's an 05 hooked up to one terminal, number 3, and it's not grounded. It's in the circuit. Oh, looks like 05. The other one could be, it's right on one of these pins here. Could be, no. Oh, look at this one. That's the audio supply into the top of the volume control, and the bottom is just grounded away. So we track this back. Wow, we're going to get the runaround. And there it is, attaching to the output of this transformer. Look at the other line. Where's the other line going? Guess this is grounded but not connected here. So you just have a diode grounded away at the top. Okay, I'm not sure I'm going to get this. Well, we know where the volume control is, so we know where the end result is, and we can also identify the ABC line easy enough, I think. Let's just follow this up. Yeah, right to a grid. Back down. So this is the ABC line. What's happening here? The ABC is developed in this tube. No, the ABC switch to, this is probably the switch on the RF control. Okay, I'm not sure. I don't think I want to spend too much more time trying to sort this out very live on video. This is the kind of thing I sit while I drink my coffee and stare at this kind of stuff. No, this might be the switch on the... no, this might be the switch. No, either one might be the switch. Yeah, exactly. Okay, well, we're going to change those two capacitors because it's pretty clear they're all kind of in sad, dilapidated state. These two are also. One of them has to be this, and the other one is the pin 6 one. Oh, I can't read the pin numbers. Let's try a different schematic here. This may or may not be exactly the same in this area. Yeah, they've laid it out quite different. The layout is totally different. Yeah, maybe I shouldn't pay attention to this. For all I know, the other schematic's not correct either. I think it's this one here. I've got an updated version of this radio or something like that. Okay, we'll just replace them for what they are. Okay, well, I've only got 3 more paper capacitors left. Well, I'm going to get rid of them. And I think I'm just going to go ahead. These are in the... this is the output tube socket here, so there's one involved there. And this is the audio amplifier or preamp tube. Might be none involved there. Hey, there's another high wattage resistor hidden back here. And there's this guy in the middle of a bunch of stuff. Okay, I will do those. Now we're going to test this radio out. Yeah, I said I wasn't going to take the time to figure out where these capacitors are, but the first one I've cut out is this one here, a 0.02, and it's right in the audio circuit. In fact, it's feeding the top of the volume control here. So all audio is passing through this 0.02 capacitor, and I'm about to change it. Okay, I got a bunch of dead soldiers here to check. Gee, that's not the best thing to say these days, is it? The universal soldier. Okay, 50 volts, and I don't know who's who here. It's just the last, this looks like six of them. It's opening up slightly. Don't even have to do another test on it, or higher voltage. That's telling the story. It's all been very similarly worn out. No, not even opening it. So, you know, as old radios go, these are not very good. So this is the one that was carrying the audio. Wouldn't have had much of a voltage, a DC voltage across it. Maybe 10, 20 volts or something like that. Let's see how it fares. Here we go. Okay, well, it's open a little more, but I'm sure at 150 it's not going to open. So yeah, bad guy too. Just because you weren't stressed in life doesn't mean you're going to live to be an old capacitor. Well, actually it did, didn't it? Because I played this radio with all these old guys in there. That was their last hurrah. Here we go. That's 150 volts. So this one's opening, but not at 150 volts. When I let go of this control, a short is put on the leads here, so the capacitor you're testing gets a short. And with them being leaky like this, they won't hold the charge anyway. So I don't, and it's only 50 or 150 volts, not enough to, not even opening on 50. Gee, when I first started, I thought, maybe I won't have to do any of these capacitors. And I've ended up doing them all. Par for the course, though. Here we go. Ah, this one's particularly bad. Okay. Put these away in the graveyard of dead guys here. And now we're going to get a chance to try this radio out with all new, well, not all new, but all the bad capacitors out. Well, I don't even know that for sure. There could be a mica in here. And you know what? I forgot to do the resistance test down here. I got carried away on capacitors. So that's still waiting. But let's try this radio out. Okay, here we go. I have outdoor antenna connected. And we're plugged in. Speakers connected. Shorted. No, nothing hooked up to the radio but the antenna. There we go. Dim bulbs looking good. There we go. Full power. Stand back a wee bit. So we're starting out on band number 1, which is the AM band. We're not too likely to pick anything up with my wire antenna, but let's see. Maybe the radio works better now. So we're up at 1500. We're not going to pick anything up. Maybe right around 860. Maybe not. Maybe around 740. Maybe not. Got the volume up pretty high here. Almost full now. Not surprised if we don't pick up anything. 590. Ooh, there's a dirty spot in the capacitor again. Well, that noise is a little bit reassuring. That's not very good. Now the solar flux index today is 107 right now. That's really poor. And we're not going to get much on this band here. So the band I'm on now is just above the AM band. So we'll just flip through it. Nothing. Next band up. We're up at 15 megahertz, so we can get stuff here. Something funny with this radio. Something going on. The volume? What's going on? Band switch. Oh, I hear something. What's up? Where does it go? Oh, could simply be the, here, let's fix this. Instead of being on the screw, depending upon the threads which are loose in the thing, let's just put them right on there. Can't be loose. Cannot be loose. Okay, we go down. So that's FT8. So sorry that it's such a hot flash on here, you can't see the dial. I wonder if I can just resolve that. Come on up close here. No, it's worse. What if I did this? That's better. Okay. So that's FT8 on the 20 meter band. We're right up in here where it says amateur.
Leave the skin healthy and baby soft. I guarantee after you discover how amazing Purple 2 products are, you'll recommend them to every... Call 778-179829. 778-179829 or visit thepowermall.com. You'll learn why so many people say it's not just soap. It's a miracle.
It's not just soap. It's a miracle. I said that about some hand soap many videos ago. Okay, this is the international shortwave band for Europe, right in this area here. Well, I guess that's probably where this was coming from. Yeah. the soap later was. So I think the band shifted a little high. Is that right? WWV, anybody? Nobody? No. Foreign.
Son unas elecciones que realmente no llegan porque saben que son delegados en utilería, delegados en poder, delegados.
A little tone control adjustment here. It's low, medium, high. Lovely. Same station twice. I'm pretty sure that's Radio Marti picking up. I wonder how many people in Cuba actually listen to Radio Marti. I think it's all the Cuban expatriates in Florida. Coming around 10, we're not likely to get.
This is an important topic. It's too often overlooked in discussion.
Picking up shortwave here, broadcast. I think WWV would be up around here somewhere. Not likely to pick it up though.
Foretells will rise at the end. It's radio.
Jerry Falwell's up there and build a thing up on top of a mountain.
You're listening to the Summer Ministry in Waltboro, South Carolina.
That costs billions and billions and billions.
Thank you.
And billions and billions of dollars. Come on, people.
Couldn't have timed that any better.
And won't make no effort to help people in ghettos and people who can't help themselves.
Nice radio. Nice to tune.
About the dominion over which they rule. In other words, rules are legal devices. Yeah, they are.
Be interesting to put this guy up against my big honkin' Hammerland radio.
Fully represent the authority it symbolized. Even today, a lot of care is taken to protect.
Okay, we're getting kind of low in frequency for this time of day. Heading down to there's a broadcast band right in this area and an amateur band. 7. Might hear FD8. Pretty dramatic. We're really getting low now. This should not be. You shouldn't be receiving anything at this time of day. It's lunchtime. Oh, it's lunchtime. I mean, we're not receiving any broadcasts. No, we're not going to hear anything down here. You put on the CW and pitch it. Hey, what's going on? What's happening there? Oh, I flipped the wrong switch. ABC on CW. There we are. Oh, it seems to be way out of, well, of course it could be the way I've got this tuned. There we are. Turn off the BFO. Nothing there. So that's teletype. Goodness knows what is going on there. In this range, who knows? I don't know. Could be everything from spy stuff to who knows. I'll leave the BFO on. When you're in between broadcast bands, it's good to turn on the BFO. There's that dirty spot. Dirty spot. We'll go to the top band. 16 megahertz. Okay, I'm going to turn off the CW. You can hear a person talking though, eh? It's interesting. There he is. So there is a technique where you set the BFO so it's zero or neutral or whatever, or sounds correct, and you can pick up sometimes stations better than you can without it. Is that true? Full of crap? Maybe I'm full of crap on that. Okay, going up. Now, you might hear shortwave up here, but 107 solar flux index. Coming into an amateur band. Could be FT8, which is quite easy to detect, to recognize. I'll put the BFO on. Nope. Dirt net capacitor. Another amateur band. I'm not doing so well up here. That's dirt in that we're hearing. And up to 40, and 43 is the top. And that's it. Well, switch off. Overall, it's working really well. So I have a few more resistance tests to do because I skipped them. We might find a resistor or two that's not right. And it's pretty close to alignment time for this radio, which looks like lots of fun doing that. And that may boost it significantly. So thanks a lot for watching, and enjoy your day. See ya.